Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 12 video on the chapter of measures of central tendency, where I will be solving 6 conceptual problems which are based on finding mean median mode of ungrouped data. So far I have discussed about how to find mean median mode of ungrouped data, and I am solving problems. Once I am done with solving problems of ungrouped data, finding mean median mode of ungrouped data, then I will discuss how to find mean median mode of grouped data. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author RD Sharma. If you find this video beneficial, then please like it, share it with your friends, and once again if you want to further support me, then please subscribe to my channel and do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 12 video, where I will be solving 6 conceptual problems as how to find mean median mode of ungrouped data. Okay, so the first problem says mode of certain scores is X. If each score is decreased by 3, then the mode of new scores is okay. So it is given that the mode of certain scores, there are certain scores and the mode is X. So if I consider, let's say I'm considering the scores to be Y and the frequency to be F. So somewhere there must be a score X, and let's say just for the sake of simplicity, other scores are A, B and C, and their frequency be F1, F2, whatever, and let's say frequency of C is F3, and let's say frequency of the score X is Fx. Now since it is given that the mode, obviously so this is the, let's say, discrete frequency distribution of the scores. Obviously we must have A not equals to B not equals to X not equals to C, because the discrete frequency distribution, the values of the variables are unique. Okay, and also since it is given that the mode of the score is X, obviously we must have Fx is greater than, Fx is max, Fx is greater than F1 comma F2 comma F3. This means that Fx is greater than all of the other frequencies, F1, F2 and F3. Okay, now it is saying that if the scores are decreased by 3, now the new when the scores are decreased by 3, what will happen? The new discrete frequency distribution will be something like this: A minus 3. The only scores are, now remember, you might be wondering whether the frequency F1 will be same or not. It will be same. Why? Because if A is not equals to B is not equals to X is not equals to C, if A, B, C, X, C are 4 unique numbers or 4 unique scores, then if you subtract certain same value from all of these scores, then those after subtraction the scores will also be unique. That is, I must have A minus 3 not equals to B minus 3 not equals to X minus 3 not equals to C minus 3. Then also A minus 3, the new scores, that is A minus 3, B minus 3, X minus 3 and C minus 3, they will also be unique. They will also be unique. So I can then say that the frequency of A minus 3 will the frequency of what will be the frequency? If each score is decreased by 3, then the mode of the new score is mode of the new score. Now if A is decreased by 3, then the value A minus 3, then the value A minus 3 A minus 3 Mm, Now, it is hard to say what will be the frequency of a minus 3, because the new value a minus 3, definitely it will not be equal to any other old value, any other values like b, x and c. Uh, mm, what is it? It is not clearly saying that whether the frequency will remain same or not. No, the frequency will not remain same. I think the frequency will become 1 over here, since a minus 3 will become, a minus 3 is a completely new value. That is, a minus 3 is definitely not equal to a, not equals to b, not equals to x, not equals to so the new values are a minus 3, b minus 3, x minus 3 and c minus 3. I think the frequency of a minus 3 will be 1, and b minus 3 will also be 1, x minus 3 will also be 1, and c minus 3 will also be 1. If this is the case, then definitely okay, one thing is that the mode of a discrete frequency distribution may or may not exist. It will not exist if none of the values or none of the frequencies is more than 1. If all the frequencies of the discrete values are 1, then we say that the mode does not exist, or the mode is ill defined. So please remember that for discrete frequency distribution, mode may or may not exist. For mode to exist, at least one frequency has to be greater than 1. Now in this problem, A, B, X and C are all different numbers. Okay, now so quite obviously a minus 3, b minus 3, x minus 3 and c minus 3 will also be different. Will also which is code is decreased by 3 in the mode of new course is, if the if each, then the a minus 3, b minus 3, x minus 3 and c minus 3 they will definitely be different, but their frequencies, I don't know. In my understanding, I think the frequency will be 1. In this case, the mode should not exist, but there are choices x minus 3, 3x, x by 3 and x. I don't know. In my knowledge, I think the frequency of all the new scores will become 1, because there will not be any other value of a minus 3 in the original in the distribution. But x minus 3. Yes, definitely a minus 3, b minus 3, x minus 3 and c minus 3 will become unique. I don't know whether it is the problem is trying to say that the frequency will remain same or not. If if the frequencies if the frequencies if the frequencies are not assumed to be same, then in my understanding all the frequencies will become 1, and this will become mode. This implies mode does not exist, because for mode to exist in a discrete frequency distribution, at least one frequency has to be greater than 1. And if, let's say, the frequencies are same, if we assume that only the scores are changing, scores are becoming a minus 3, b minus 3, x minus 3, c minus 3, and the frequencies are same, then obviously the frequency of x minus 3, then fx is the maximum, so the mode will be x minus 3. I don't know, so this question is not very clear to me, so I'm sorry I could not properly solve this problem. If you have a clarity of this problem and you know the answer, then please feel free to let me know in the comment section. I will highly appreciate that. By the way, the question is correct, the statement is correct, but the choices were framed by me. So maybe I have incorrectly given the choices. So I will appreciate if you can help me out in providing me the correct explanation of what the problem is asking. That is, whether the frequency will remain same, or the frequencies will become all the frequencies will become 1. Let me know. I will appreciate that. Okay, let's see the next problem. If median of the scores x by 5, x by 6, x by 3, 2x by 5 is 16, where x is less than 0, x is negative, then the value of x is. Okay, so we are given some numbers in terms of x. It is given that the median is 16. How many numbers are there? 1, 2, 3, 4. Even numbers. N is 4. N is 4. Even number of observations. So definitely, first we have to sort the numbers in either ascending or descending order. I will try to sort the numbers, these 4 numbers, in ascending order. Now, keeping in mind that x is less than 0. Okay. Now, one concept you must understand, that let's say if for x less than 0, x, if I divide x by a, where a and b, x by a will be less than x by b if a is less than b. If a is less than b and both a and b are greater than 0. If a and b are some positive numbers, x is negative, and if a and b are some positive numbers where a is less than b, then x by a will also be less than x by b. Because x by a is 1, x by a is nothing but x multiplied by 1 by a. X multiplied by 1 by a. Now, if a is less than b, a less than b implies the reciprocal. A and b are positive numbers, and if a is less than b, then their reciprocals, the inequality will get reversed. That is, a by 1 by a will be greater than 1 by b. Now, so 1 by a is greater than 1 by b, and 1 by a and 1 by b are both positive. Then we must have x multiplied by 1 by a should be less than x multiplied by 1 by b, where x is negative. X is negative, so the total, the numerical value of x by a is more than the numerical value of x by b. But since x is negative, then this will be less than this. So this is a concept that we need to understand for sorting the given numbers. So quite obviously, then I will have which will be the least number. I am trying to sort the number scores in ascending order. So which will be the least? The least will be where the denominators is least. Remember, the denominators of the first number is 5, the second number is 6, the third number is 3, and the fourth number, last number, you can this 2x by 5, you can consider this as x by 5 by 2. So the denominator you can consider as 5 by 2, which is 2.5. 2.5. So obviously I must have 2x by 5 should be less than x by 3 should be less than x by 5 should be less than x by 6, where we know that x is negative. Okay, so this is the numbers in ascending order. Then since n is 4, obviously the median will be the mean of these two, the second and third position. Second and third position, the mean of the second and third observations. So median should be equal to x by 3 plus x by 5 whole divided by 2. This is equal to x by 3 plus x by 5 is how much? It is 8x by 15. So we have 8x by 30. 8x by 30 is the median. Now the median is given to be 16. So we have 8x by 30 is equal to 16. This implies x is equal to 60. I have incorrect, while I was solving the problem, I have incorrectly given the choices. I thought the answer would be 30, because when I was solving the problem, I forgot the median is x by 3 plus x by 5 divided by 2. I forgot to divide it by 2. So if you do not divide it by 2, then x will come out to be 30. So that's the reason I gave 30 as a choice. So it's my mistake. The x is 60. X is 60. The value of x should be 60. Okay, let's see the next problem. Question number 3. If the mode of the scores, some scores are given and the last score is x, is 4, then the value of x is. Then the value of x is. Okay, so the one way, let's say x denotes the scores, you can quickly prepare the discrete frequency distribution. So okay, let's say the one way is to solve this problem is to you assume all the values that are given in the choices. Let's say if x is 6, if x is 6, then what we will have? We will have 3, frequency will be 2, 4, frequency will be 2, and 5, frequency is 1, and 6, frequency is, let's say, let's not consider any value for the x. Let's try to prepare the discrete frequency distribution as it is given. So we are having 2 3s, we are having 2 4s, 1 5, and 2 6, and there is x, we don't know. Now x could be any one of the values. The x could be any value, but it is given that the mode is 4. Now mode is 4, which means that mode cannot. So now this is common sense based on the fundamental concept of scores. If can score be the value of x surely cannot be 3 or 6, because if it becomes 3, then the frequency of 3 becomes 3, then the mode will be 3. The value of x cannot be 6, because if value of x is 6, then the frequency of 6 will be 3 and the mode will become 6. Forget about 1. Now if the value of x is 5, if the value of x is 5, then the frequency of 5 will be 2, then there will be 3 modes. 3, then there will be 4 modes, 3 4 5 6, all will be the modes. No, so if now the value of if the value of x is 4, then only you will see that the frequency of 4 will be 3 and the mode will be 4. Since it is given that the mode is 4, so obviously the value of x has to be 4. Now there was no as such mathematical any strategy or formula. It is this problem is just based on the concept of mode, that is the value in a discrete frequency distribution whose frequency is the maximum. Okay, let's see question number 4. The mode of the observations, some observations are given where x is greater than 0 can be. The mode of the observations can be, some observations are given and it is asking what can be the mode of the observations be, because the x is unknown, we don't know the value of x. So do we need to find the value of x to understand what can the mode be, because all the choices are given constant values, they are not given in terms of x. Now obviously one thing is clear is that when okay, so the mode of the observations, so raw observations are given, now we have to first figure it out, what are the unique values, what are the unique observations. Now okay, so 2x plus 3 2x plus 3, bottom 2x plus 3 can never be equal to 4x plus 3. 4x plus 3 is an observation, 2x plus 3 is also an observation. Now 2x plus 3 can never be equal to can never be equal to 2x plus 3 can never be equal to 4x plus 3, because if 2x plus 3 is equal to 4x plus 3, we will get the value of x as 0, but it is given x is greater than 0. So these two are unique. These two has to be unique observation. Okay. Now okay. Again, x minus 1 cannot be equal to 3x minus 1, because if x minus 1 is equal to 3x minus 1, then minus will cancel out, then also we will get x equals to 0. So x minus 1 and 3x minus 1 are two unique, they are different, they are unique observation, and also 2x plus 3 and 4x plus 3 are unique observation. Okay. Now 5x plus 2. Now can 2x plus 3, can any observation of these two be equal to any observation of these two? They are not equals to this. Okay. Can 2x plus 3 be equal to x minus 1? If I'm trying to see whether 2x plus 3 can be equal to x minus 1 or not. If this is so, then I will get x is equal to minus 4, which is not possible because it is given x is greater than 0. So obviously not possible as it is given x is 0. So 2x plus 3 is also not equals to x minus 1. So then this will imply that 2x plus 3, 4x plus 3, x minus 1 and 3x minus 1 are all unique. For whatever value of x greater than 0, these four observations has to be unique. Okay, they are unique. Now the only remaining observation is 5x plus 2. 5x plus 2. Now I have to check whether 5x plus 2 can be equal to any one of these observations or not. So that we get a value of x which is greater than 0. So 2x plus 3, can it be equal to 5x plus 2? Is it possible? No, because in this case this will imply x will be equal to how much? X will be equal to okay, so x will be equal to, it is possible I think, 3x will be equal to 1, so x will be equal to 1 by 3. This is possible. So 5x plus 2 can be equal to 2x plus 3, which will then imply then the value of x will be 1 by 3. Okay, fine. So then 2x plus 3 and 5x plus 2 will be equal, and so they will be equal, and we will have an observation with frequency 2. Okay, now let's see, can 4x plus 3 be equal to 5x plus 2? This will imply x is equal to 1. So this is also possible. X is equal to 1. X is equal to 1. 1 by 3. x is equal to 1. So this implies 7. So we are having, so this implies that 4x plus 3 will be equal to 5x plus 2 will be equal to 7, and there is 7 in one of the given choices. So if 4x plus, if x is equal to 1, we are having two occurrences of the value 7, because 4x plus 3 and 5x plus 2, they will their values will both be 7. So we will have two occurrences of 7. So 7 is a possibility. 7 is a possibility. Now let's see whether we have also if if 2x plus 3 is equal to 5x plus 2, then we are having x equals to 1 by 3. So this implies 2x plus 3. In this case also, if x is 1 by 3, then we are having 2x plus 3 is equal to 5x plus 2. Then also we will have two occurrences of an observation whose value will be 2x plus 3, where x equals to 1 by 3, which is 2 by 3 plus 9. This is 11 by 3. But 11 by 3 is not in the given choices. All the given choices are integers. Okay, now let's see if x minus 1 can be equal to 5x plus 2. Is this possible? Will from this, can we get a value x greater than 0 such that 5x plus 2 and x minus 2, x minus 1 will be some integer? No, this will imply x will be equal to minus 3 by 4. Not possible. This is not possible because it is given x is greater than 0. So the last thing we need to check is that if 3x minus 1 is equal to 5x plus 2, this will imply, this will also imply a negative value of, this will also give a negative value of x, which is not possible. This will give x equals to 2x minus 3 by 2. Not possible. So clearly we can see that if when x equals to 1, we are having two observations, that is 4x plus 3 and 5x plus 2, they become equal to 7. So we will have two occurrences of 7. So 7 is the choice C is the correct choice. 7 can be the mode. That is, when x is equal to 1, we will have two occurrences of the value 7. Okay, let's see the next problem. The median of 21 observations is 18. The median of 21 observations is 18 if two observations 15 and 24 are included to the observations. Then the median of the new series is, two new values are added, which are 15 and 24. Okay, so the one thing is that, let's say I have some observations x1, x2, which are already in the sorted order. Let's say in the ascending order, x1, x2 up to xn are observations in ascending order. Let's say some xi somewhere in between, depending on n, let's say xi be the median. Xi is a median. Obviously I will be n plus 1 by 2 if n is odd, and I will be and if n is even, then consider for the sake of simplicity n is odd. That is, xi is the median, xi is the middlemost observation in the sorted list of observation x1, x2 up to xn. Now the thing to understand is that if I introduce a value a which is less than the median, then it will be then in the sorted list it will be somewhere to the left of a less than xi. Xi is the median, and if I add a new value a to the observations, and I know that a is less than the median, then obviously in the sorted list of observations a will lie to the left of the median. and if I add another value b which is greater than the median, it does not matter how big it is, just b is greater than the median, then obviously in the sorted observations b will lie to the right of the median. In that case, the xi will still be the median of the new observations where I have added a and b. Xi, the median, will never change. So in this problem it is given that the median, there are 21 observations, so n is odd, and so obviously and the median is 18, so I have 18 is median. I have some values to the right hand side and I have some values to the left hand side of the median. Obviously, since there are total 21 observations, then over here to the left hand side of the median there will be 10 observations, and to the right hand side of the median there will be another 10 observations, and all the observations to the right hand side of the median are greater than 18, and all the observations to the left hand side of the median are less than 18, because I am considering all the observations, 21 observations, to be sorted in ascending order. Now event 15 is added. Obviously 15 will be added over here. 15 will be in the sorted list of observations. 15 will be to the left hand side of 18, and 24 will be to the right hand side of the 18. Now when two observations are added, the total number of observations is becoming 23, which is odd. And then after adding 15 and 24, since one value is being added to the left hand side to smaller than the median, and one value which is 15 and another value 24 which is being added to the observation which is greater than 18, then always remember that the median will remain the same, that is the median will be 18. Since again the total number of observation is 23, which is odd, so and the number which is greater than 18, which is 24, will be to the right hand side, and the number which is less than 18, which is 15, will be to the left hand side of 18. So you can clearly understand that the median will still be 18. But if in the problem it was that only one number was added, that only 15 or only 24, then the total number of observations would have been 22, and the median would not be the same. The median will not be 18 in the new observations. It will change. But since we are adding one value less than the median and another value greater than the median, always remember that the median remains the same. So if you are given an odd number of observations, and if you are told a median, if you are given an odd number of observations and you know the median, and if two values are added to the observations, one is less than the median and one is greater than the median, always remember that the median will remain the same. So in this case the median will still be 18. So the correct choice is B. Let's see the question number 6. If P is less than Q is less than twice P, the median and mean of P, Q and 2P are 36 and 31 respectively. Then find the mean of P and Q. So it is given that the observations are P, Q and twice P, and these are, since it is given P is less than Q, Q is less than twice P, then this observation is in ascending order. Okay, then the median is obviously Q. Q is the median. Since the number of observations is 3, which is odd, then the middlemost element will be the will be the n plus 1 by 2. N is 3, so 4 by 2, that is second element. So median is q. Okay. So this implies the median in the problem is given to be 36. So I have q is equal to 36. Also the mean is given to be, the mean is given to be 31. The mean is 31. What is mean? Mean is P, the sum of the observations, divided by the total number of observations. The number of observations is 3. This is equal to 3 P plus Q by 3. And Q we already know is 36. So this is 3P plus 36 divided by 3. Now the mean is also given to be 31. So we have 3P plus 36 by 3 is equal to 31. So this implies doing cross multiplication, I have 3P plus 36 is equal to 39. This implies 3P is equal to 39 minus 36, which is 3. So this implies P is equal to 1. So we have found the value of Q to be 36 and P to be 1. So this implies it is asking the value of mean of P and Q. So mean of P and Q is nothing but their sum divided by 2, which is 1 plus 36 divided by 2, which is 37 by 2, which is 28.5. So 28.5 should be the mean, and there is no choice. I think I have done some mistake in calculation mistake. Let me see. The median is given to be 36 and mean is given to be 31. Okay. So the median is obviously Q, because P is less than Q is less than 2P. So if I sort the three observations in the ascending order, it will be P comma Q comma 2. So the middlemost element is Q. That should be the median. So Q has to be equal to 36. Okay. Now the mean is the sum of the observations divided by the number of observations, which becomes P plus Q plus twice P divided by 3, which is 3P plus Q divided by 3. Q we know is 36. So this is 3P plus 36 by 3. Also the mean is given to be 31. So we must have 3P plus 36 by 3 equals to 31. This implies 3P plus 36 is equal to, this is not 39, but this is 60. This is 93. This is 93. Okay. So we have 93 minus 36, which is 93 minus 36, which is 757. P is 57, so this implies P is 57 divided by 3, which is 19. So P is 19. So then the mean of P and Q is P plus Q by 2. P is 19. P is 19. So we have 19 plus 36 divided by 2, which is 55 divided by 2, which is 27.5. So the mean of P and Q is 27.5, which is choice C. So with this, it brings to an end in solving 6 conceptual problems based on the mean median mode of ungrouped data. I will solve, probably I will make another 2 sets. If not 2 sets, definitely one more set on finding mean, median and mode of ungrouped data. Then I will discuss how to find mean, median, mode of grouped data. That is where we have class intervals, continuous class intervals, discontinuous class intervals, how do we find mean, median, mode of those group data. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel. Do not forget to press the bell icon so that you will be notified by my future videos. And as always I say, if you find any difficulty in understanding any solution, any steps, or any concept that I am applying, please feel free to let me know in the comment section. I will definitely do my best to help you out, address your query, and address so that your doubts are clarified. So that is all for this video. I am ending the video here. Thanks for watching, and until the next video, take care and bye.